Welcome to This Explainer. Today, we're diving into a 500-year-old engineering cold case to answer a surprisingly fun question. Was history's greatest genius actually kind of bad at math? We're talking about Leonardo da Vinci, right? Known universally as this brilliant polymath, artist, and visionary engineer. His contributions to science are literally legendary. But hidden within his salvaged notebooks was this bizarre mathematical claim about friction that basically baffled modern engineers for decades. So today we're going to explore how a team of modern researchers essentially turned into historical detectives to recreate his exact experiments and solve this mystery once and for all.
When you actually dig into his salvaged writings, you find statements that prove Da Vinci understood the fundamental laws of dry friction centuries before anyone else even had a clue. He recognized an absolutely core principle of tribology. The force of friction is completely independent of the apparent contact area. Meaning, whether you slide a wooden block on its wide, flat face or tip it up on its narrow edge, the resistance remains exactly the same.
To really put this timeline into perspective, Da Vinci documented these laws way back in 1493. But because his notebooks were hidden away for centuries, it took over 200 years for the French physicist Guillaume Amontons to rediscover these exact same laws in 1699. And then it wasn't until 1785 that Charles-Augustin de Coulomb expanded on them. So Da Vinci was literal centuries ahead of the curve here.
Which brings us to our first real puzzle, the universal quarter mystery.
Despite his incredible foresight, Da Vinci's unpublished notebooks contained one glaring, fundamental error, right alongside those brilliant deductions. He claimed that the coefficient of friction, which is just the ratio of the frictional force to the normal load pressing two surfaces together, had a constant universal value of 1/4, or 0.25, for absolutely all dry solids. He firmly believed that any object had a friction resistance equal to exactly 1/4 of its weight, no matter what material it was made of. Now, today, we know a universal coefficient for all materials is a physical impossibility, right? Rubber sliding on asphalt is completely different from ice sliding on steel, which raises a massive question. How did a meticulous, brilliant mind like Da Vinci's make such a monumental mistake? Did the ultimate Renaissance man just guess or forget to carry the one?
To find out, we have to rebuild the past. Let's look at recreating the Renaissance apparatus.
A team of modern researchers decided to stop guessing and start building. They took Da Vinci's original experimental schematic straight from the Codex Arundel, which showed a rectangular block on a table connected to a hanging mass by a thin string running over a cylindrical pulley, and they built a faithful modern recreation. They crafted the testing table from solid machined curly maple wood and the pulley from West African bubinga. But here's the clever 21st century trick. Inside that wooden pulley, they concealed a precision steel shaft and rolling element bearings. They did this to completely eliminate any parasitic friction from the pulley itself, ensuring that they were only measuring the friction of the sliding wooden blocks, exactly as Da Vinci intended to do.
Once built, they ran the tests using rigorous modern laboratory practices. They didn't just grab scrap wood from a hardware store. They used machined African padak wood for the sliding blocks, sanded them incredibly gently with 600 grit paper, wiped them completely spotless with low lint cloths, and then actually let them equilibrate for over a year. This is exactly how you would meticulously isolate variables in a modern tribology lab today.
So what happens next? Let's get into the clean versus rough tests. The real question is, what happens when Da Vinci's Renaissance physics actually meet a modern 21st century lab environment? Well, when the engineers tested that clean, modern preparation, they found a friction coefficient of 0.72, which is nowhere near Da Vinci's 0.25. So the team completely pivoted to what they called a Renaissance preparation. They swapped in brusquely squared, totally unpolished wood, intentionally sullied it with natural hand oils, and then scattered fine olive wood dust all over the surfaces to simulate a bustling, messy 16th century workshop. And the data shift was immediate. While the clean, modern wood sat way up at that 0.72 mark, the very moment they tested the rough, dusty, sullied wood, the friction coefficient plummeted to exactly 0.25. It hit Da Vinci's number perfectly. It turns out introducing that fine olive wood dust and entirely skipping the modern sanding process completely changed the physics of the interaction. In modern tribology, we actually know that layers of dirt, dust, and oils act as a natural solid lubricant. They prevent microscopic jagged edges on the wood from interlocking with each other.
By perfectly recreating the environment of a working Renaissance studio, the friction dropped right to that magical 0.25 mark.
And this leads us to the big reveal, a dusty laboratory.
Here's the profound takeaway. Da Vinci wasn't guessing at all, and he certainly wasn't bad at math. His quote-unquote universal 0.25 coefficient was actually an incredibly accurate empirical measurement of his specific everyday reality. He was working in a dynamic, active Renaissance workshop where clean, sterile, perfectly sanded surfaces just didn't exist. For rough-hewn wood, handled extensively with bare hands in a sawdust-filled room, 0.25 was absolutely 100% correct.
So the modern researchers ultimately concluded that what had seemed like a massive historical blunder for decades was, in reality, a flawless reflection of the world Leonardo was living and working in. He accurately measured the physics of his own sullied, rough-hewn Renaissance reality. It really leaves you wondering, doesn't it? As we look back at the grand history of science, how many other seemingly flawed ancient laws or mathematically incorrect calculations are actually just highly accurate snapshots of a world that simply no longer exists? Da Vinci was right all along. We just had to make our labs a little bit dirtier to finally see his genius. Thank you for joining me on this explainer. Keep questioning, keep exploring, and I'll catch you next time.